Hello everyone, welcome to another exciting session. I hope all of you are doing well. Yes, good to go. I welcome you all in another exciting session for ICSE Physics Term 2. And the topic that we are going to discuss today is, alternating versus direct current. And more importantly, we'll be discussing the basic working principle of a transformer, right? We'll be discussing the basic working principle of a transformer, right? Fine. And this happens to be a part of electromagnetism. The entire topic is a part of electromagnetism in class 10 term 2. Now, in case you are attending my session for the very first time, let me introduce myself. My name is Kalyan Krishna Awasthi, and as far as my qualifications are concerned, I have done my masters, I have done my MTech in electronics with my area of specialization as digital communication, right? Digital communication happens to be my area of specialization, and right now I'm pursuing my PhD in electronics with wireless sensor networks as my area of specialization, and I've been teaching physics since 2008. So I have a teaching experience of more than 12 years. That too, I've been teaching physics for more than 12 years, so I have that you know idea of how the questions are asked in the board examinations, what all they expect from the students to write in their answer sheets, so you can take advantage of my vast experience. Fine. Next, in case you have not connected with us through Telegram, so this happens to be the link. You can see in this particular slide you have got two links. This link is for the general ICSE and ISC board Unacademy group, where you'll be updated with all the upcoming sessions and all. And this is my group, the physics group at Unacademy. So I would expect all of you to join both the groups so that you are updated with all the current information, all the updated informations, what all offers Unacademy is bringing for its students, for its learners. Each and everything is updated on these two groups, right? Okay, so let's start the session. The session, first of all, let me brief you the course of session. The session is divided into two parts. In the very first part, I'll be discussing about very common topic, alternating current versus direct current, why, which of them is more advantageous, and why, what more often do we use an alternating current or a direct current. So this is all I'll be telling you. And then in the later part of the session, I'll be telling you an application, that is transformer. I'll be telling you how a transformer works, what are the constructional details of a transformer, you know what are the functional details, how can you calculate the efficiency, what all losses a transformer has. So I'll be kind of briefing you about everything in the later part of the session. So let's start the session. The very first thing that comes in our mind is what is the core difference between alternating and direct current. So I have rather taken up a you know comparative chart to elaborate the difference, but I'll be telling you through diagrams as well. See, direct current always has a constant magnitude. Now when I'm talking about magnitude, what I mean to say is, when the time changes, the current does not. Okay, the current remains constant. Let us try and draw this. Let this x-axis is time, this y-axis is current. Let us say the value of the current is 3 ampere. Okay, these are different instances, say 1, 2, 3, 4, 5. The time axis is in seconds. So what I observe, at at t is equal to 0 the current was 3, at t is equal to 1 the current was 3, at t is equal to 2 the current was 3, at 3 the 3, 4, 4, 5. So if I join these dots, what I get is a straight line. Yes, when I join these dots I get a straight line. And what does this straight line signify? This straight line signifies that the magnitude of the current is rather not changing. See, at all these points, the current was indeed 3 amperes. Yes, at all these points the current was 3 amperes. So this signifies that the magnitude of the current is not changing, right? So this sort of a current is a direct current. This is a direct current. Okay, and then you have one more form of current which you call alternating current. And what does alternating current means? What is the technical meaning, what is the physical significance? If I try and explain you through a graph, This happens to be the value or the waveform of an alternating current. See, the word alternating means changing. Alternating means changing. Changing means to alternate, right? Alternating means to alternate. I mean, alternation means periodic change. Alternation means periodic change. So, what does a AC current do? It periodically changes its value. And when I'm saying periodic, what do I mean to say periodic? Period means a periodic signal means a signal which repeats its value after a fixed interval of time. Okay, a periodic signal is one which repeats its value after a fixed interval of time. It's like if I'm saying that if a particular train leaves a platform daily at 10 p.m., then 10 p.m. is the time when every day the train will leave. So the frequency or the motion of the train is periodic. This is how we perceive periodic motion, right? So far so good. I hope you've understood. This is how we perceive periodic motions, right? So an alternating current is always periodic. I mean, we'll be discussing uniform alternating periodic currents. I mean, this is what is there in your syllabus. So you can clearly see that the current is repeating its path. This is the fundamental period. Then again a same pulse and again. I mean, it will extend till infinity the same way. So this is a periodic signal. Okay. Now you can clearly see if I say this is plus 3 ampere. So obviously it has to be minus 3 ampere, right? So what is happening? The current is alternating. It is changing its value. Here it was plus 3, then here it was minus 3, then again here it will be plus 3, then again here it will be minus 3, and it will keep on alternating this way. And since it is alternating, we call it alternating current. Yes, here it was positive, and in the next cycle it was negative, so it periodically reverses its direction. Okay. And how can we get a direct current? We can get a direct current through a cell. This is a cell, and a series combination of cells is a battery. I mean, if you put a cell or a battery in any circuit, you will get a direct current. And in case you wish to have an alternating current, you can use a generator. I mean, generator, the word itself tells you something is being generated, and which sort of current is generated. An alternating current is generated, right? So this is how we generate and talk about direct and alternating currents. Now let's see which current should we preferably use. I mean, obviously, if in case a particular current is advantageous over the other currents, I'll be using it. So in general, this is very subjective. In general, we use AC. Why? Because AC is advantageous, and these are the advantages that an alternating current offers over a direct current. The very first thing, it is easy to generate AC, and it is cheaper. The cheaper part is the best. Obviously, the efficiency, it has an added advantage of being efficient, and you can anytime step it up or step it down. Okay, you have the facility of stepping up an AC voltage and stepping down it either through transformer, which I'll be telling you. I mean, how to step up and step down, I'll be telling you in this particular session only. Okay. And the best part, it can be transmitted over a very long distance with minimum losses. We have had a word on this while we were discussing household circuits. If you remember, in household circuits, when we were discussing the transmission of power over a long distance, that particular session, yes, so there I told you it is always advantageous to use AC because they can be transmitted over a very long distance with minimum losses. Okay, so these are few advantages of AC over DC, which you have to keep in mind because they often ask a 1 marks question in your board exams, so you cannot afford to kind of do that question incorrect, right? So very easy, very conceptual as well, and with a lot of practical advantage, right? Okay. Now, before starting with the transformer part, I would like to tell you about the Unacademy free special class features. See, if in case you're watching this particular session, so you're watching it on YouTube, YT sessions, in YT sessions we can interact through chat box, but it's not a live interaction. I mean, there is a lag between you and me, or for that matter, if a number of students shoot a doubt simultaneously, at times it happens. Okay, Abhinav Sharma has to say something. Yeah. Three examples from real life are what when we light a stove, we can feel the heat, okay. Second, we can see light, okay. And third, when we don't find our books, we call our moms. That is the stuff. The third one is the first law of motion. Okay, I mean, now you have rather given very realistic examples. The third one was a little bit abstract, but it can be counted for it. Okay, that's good. I mean, we just had a podcast and you were there and you came up with a solution quite early. That's very commendable. Good, fine. I'm sorry, I'm having a very bad throat, so I have to take medicines regularly. Excuse me for that. Okay, I was telling you about this Unacademy special class feature. See, like in YT, you have just seen a student Abhinav has dropped in a message. So there was a lag between the time he sent the message I received and I replied, and it might happen that I am into something, I'm explaining something, and I skip few of the messages. That might be a possibility, but that's not the case with special class feature because you get to interact with the educator live. This is the best part. The interaction part is pretty live. Okay, so it removes that lag, and the best part is you have the option to ask your doubts. I mean, at any point of time, if you have any doubt, feel free to ask to the educator. The educators are more than happy to help you out. This, right? And on top of that, we have live polls. And what do you mean by live polls? Live polls means we have a number of MCQ session where the students participate and we get to see who is leading the leaderboard. You can clearly see by the end of the session, we do have a poll summary which tells you which particular educator or which particular learner was leading the board. So it kind of generates a sense of competition, which obviously gives you an added advantage, right? Now let's move on to the topic transformer. Fine. All of you have seen transformers? Obviously, yes. I mean, they are placed outside our houses, they are placed on the ground floor of the flats, rather everywhere. So what do we use them for? We can use them to uh, change the magnitude of the EMF. Okay, rather, if I talk about the principle, first of all, the EMF is induced because of which current flows in the circuit, and automatically you take that output current. I'll be telling you about that maybe in 2 to 3 slides. What is the working principle? The working principle is obviously electromagnetic induction, right? The working principle of a transformer is electromagnetic induction. Induction, as I've told you in yesterday's podcast, induction means a body is not having certain properties, but those properties have been inherited from some other body. So if some other body induces a particular property in the parent body, we call it induction, right? We call it induction, right? And another part, the transformers do not affect the frequency of the alternating voltage. Now, see, this is a very important question. You know what the frequency is? The frequency here is 50 hertz. I mean, few of them regard it at 51, but technically speaking, it's 50 hertz. So it's not that the transformer will alternate the operating frequency. It never operates the alternating frequency, right? Yes. Is it clear? Now, there is one very important point. Okay, before discussing that point, let me tell you a very interesting thing. Transformer never works on DC. Now let me write it. Transformer works on AC. It does not work on DC. And why doesn't it work on DC? See, the basic principle is electromagnetic induction. If it is obeying electromagnetic induction, in that case, there has to be a change in flux. If the flux is not changing, no EMF will be induced. And if no EMF is induced, you're not going to get any induced current. I hope you're getting the logic straight. See, the final output is an induced current. For that, there has to be an induced EMF. And for the induced EMF, the flux has to change. How? In accordance with Faraday's first law. Yes, if I'm not wrong, in accordance with Faraday's first law. Yes, Faraday's first law of electromagnetic induction. What does this law say? Whenever there is a change in the flux, an EMF is induced due to which a current flows in the circuit. Okay, the final product or the final outcome is a current. But how does this current flow? The current flows because of the change in the EMF. And why does this EMF change? The EMF changes because of the change in the magnetic flux. Okay, the same thing happens in the transformer as well. If you are using a direct current, so I have just told you excuse me, I have just told you the basic difference between a direct current and an alternating current. Yes, and what is the difference? A direct current has a constant magnitude. Yes, you're getting that point. Direct current is having a constant magnitude. Once the magnitude of the direct current is constant, now you tell me, is it possible to vary the current and have a changing flux? No, you cannot have a change in flux with a constant current. So I mean, practically, if you ask me, what happens if there is a constant current or if you increase a DC current? I mean, the DC current will increase in a constant proportion. It will keep on increasing, and what will happen? The primary windings of the transformer might be damaged. So, you cannot use a DC current for the operation of transformer. Few of these students might say, sir, we have seen somewhere, you'll be Googling it, you will find a DC transformer. Okay, no problem. What actually happens? They employ AC DC converters. Okay, so that is not what we have to discuss in class 9. That's a very engineering concept, so we're not going to discuss it here. Technically speaking, as of now, transformers never work on DC, they always work on alternating current, right? Good to go so far. I hope you're finding the session interesting. If yes, you can just drop in a thumbs up in the chat box. I'll get to know. Okay, now let's see the constructional part. How can you construct a transformer? Fine. See, I have just elaborated the parts that are required for the transformer. We need a primary coil. Okay. We do need a secondary coil. We need a core. Okay. And there are something very specific about the cores. The core is always laminated to prevent the loss of energy due to eddy currents. Now, this is a relatively new term for you. Anyone knows about this? What are eddy currents? Eddy currents? Any one of you? Okay, fine. Can you tell me the literal meaning, the Hindi meaning of eddy? Eddy, I mean, that way you'll be able to relate it. I mean, it will give you a better replication of that. Eddy, you can assume it like, you have seen bhavars, bhavre. I mean, on the surface of the water, bhavar jo banta hai, like this way, right? So, okay, fine. So, what happens? Eddy currents are formed because there are certain components of the magnetic field which create a surface current. This surface current at times creates a magnetic field which opposes the main magnetic field. We don't have to dwell deep into that. You only have to understand that eddy currents at times they generate an opposing magnetic field due to which there are a lot of losses. I mean, if you have a forward magnetic field and certain currents, yes, Abhinav, circular movement of water. I have told you bhavar. I mean, you call it bhavar, okay? In layman language, you call it bhavar. So, if an opposing magnetic field is anyways developed, what will happen? It will, kind of oppose the main magnetic field. Once the main magnetic field is opposed, what will happen? Obviously, there will be a decrement in the net flux and the efficiency will decrease. Okay, so this is what we do. We laminate the core to prevent the losses. Okay, now the core is also designed with certain specific constraints. And what is this? It is always designed with a soft iron. And why do we design a core with a soft iron? To avoid hysteresis losses. Now again, hysteresis loss is again a relatively new term for all class 9th or 10th students. Anyone knows what hysteresis loss is? Or else I'll be telling you about this. No issues on that. Anyone, what are hysteresis losses? Okay, these losses occur when there is a frequent magnetization and demagnetization. Let me brief you about this. When there is a frequent magnetization and demagnetization, then the sort of losses that incur, they are called hysteresis losses. Okay, these are what happens. I mean, I have to dwell deep into it to make you understand. Have no problem. There are certain regions called domains in the magnetic materials. There are three types of magnetic materials: paramagnetic, ferromagnetic, and diamagnetic. Let us consider a ferromagnetic substance. I mean, magnetism is more prominent in the ferromagnetic substance. There are certain dipoles within the region. Okay, so what happens if an external magnetic field is applied? These dipoles align themselves in a particular direction, and when this magnetic field is removed, they again go back to their original orientation. So what happens if a substance is magnetized and demagnetized? Then there is periodic alignment and de-alignment of these domains, which cause a lot of loss. Okay, so to avoid these losses, we have to use a soft iron core. What does soft iron core do? I have told you its function in the working of electric bell, right? High permittivity and low retentivity, right? This is a very specific factor. Now there is one again constructional constraint. I have told you that we have a primary coil at the primary side, we have a secondary coil at the secondary side, and what we do, we ensure that the number of turns on the primary and the secondary are different, right? Now, why do and what do the number of turns do, I'll be telling you in a while. The step up and the step down operation is based on the number of turns. I'll be mathematically showing you what happens if we change the turns. I mean, in one case the voltage will be stepped up, and in the other case the voltage will be stepped down, right? Okay, now let's see a working diagram of a transformer. See, I'll be showing you a diagram that you can relate with. I mean, don't compare it with the diagrams that you find in the book. Okay, I'll be telling you a more relatable diagram. See, the constructional part said that it has to have primary coils and secondary coils, and on top of that you need a core. Let us suppose that this is the core. This is the core of the transformer, right? What they do, in your books you will find, you know I am giving you a top view of the transformer. So just don't get confused with the diagrams in your books. We use a number of sheets instead of using a single wire or a single sheet. We use a number of sheets to ensure that the losses are less. Okay, now see, what they do is, just try and visualize. This is the primary side, and this is the secondary side, right? So far so good. I hope you are able to relate with it. This is the core of the transformer. This is your primary side, and this is your secondary side. Now what happens? How does a transformer work? Before understanding the working, you have to kind of remember one very important parameter that we call turn ratio. Turn ratio. We represent it with n, and this n is given as number of turns in secondary divided by the number of turns in primary. Okay, this value will give you the turn ratio. This is the primary side. Let us suppose that the number of turns are NP and the potential EMF at the primary side is EP. Let us suppose the number of turns at the secondary is NS and the EMF induced is ES. Okay, so far so good. I hope there is no problem. And this happens to be the turn ratio. Okay, we also call this transformation ratio. In few books you'll see transformation ratio as well. So don't get confused. Both of them mean the same thing, right? I hope you understood what a transformation ratio is. Yes. Okay. Now see. You can write it as ns upon np. That will go. So for me, n is equal to ns upon np. Okay, that's good. Now one very important thing. Tell me, what will be the total EMF generated? I mean, at the primary side, let me tell you a very basic replication of how things happen. We apply an input voltage, okay, an input alternating input, and an alternating input, an alternating EMF. What happens when an alternating EMF is applied? The flux here changes. I mean, initially, let us suppose that no source was there, so no flux was generated. Here, there was no flux, but once the source is generated, what will happen? The flux at the primary side will change. Now you see the same flux through a closed wire, through a closed coil, is related to the secondary as well. Initially, when no flux was passing or no flux was changing from the primary side, no flux was changing at the secondary side either. But once the alternating input was applied, the flux at the primary side started changing. And once the flux at the primary side started changing, the same flux was linking the secondary side as well. Now the flux at the secondary side also changes. And what does Faraday's laws of electromagnetic induction say? They say that whenever there is a change in the magnetic flux, an EMF is induced, right? So see, you didn't had a supply here, but because of induction, an EMF is induced here. This process is called mutual induction. Okay, you'll get to know this term in the higher classes. This process is called mutual induction, and because of this mutual induction, a flux is changed at the secondary side, and obviously an EMF is induced, due to which a current flows. I mean, if you connect a bulb here, the bulb will glow. You did not supply current here, you just applied an alternating current here, and what you will see that the bulb here will glow. I mean, rather I should call it a load. The load here receives the current. Yes, this is the input part, and this happens to be the output part. Yes, I hope you're getting my part. My logic, the logic is clear to all of you who are attending the session. Yes or no, all of you? Okay, I guess yes. If you're not replying, I guess yes. Okay, now let's talk about the equations. I mean, the mathematical equations that are involved in the working of a transformer. Okay, see, I've told you one thing, that ns and es, these are the number of turns at the secondary side, and np and ep, the number of turns and the emf at the primary side. Okay, now the transformer has one very basic funda. If I tell you the current at the primary side is is, secondary side is is, and the current at the primary side is ip. Is and ip are the currents at the primary and the secondary side. Now tell me, what will be the power generated at the primary side? Like, P is equal to V into I. We have studied this. So at primary side, the power generated will be EP into IP. Yes, this will be the value of the power generated, right? And what power will be generated at the secondary side? It will be ES into IS. Yes, I hope you understand this. This is very logical. Now, if I say that I am having an ideal transformer, let us suppose that I have an ideal transformer. Now, what does this ideal transformer means? Ideal transformer means that input power will be equal to output power. I mean, whatever power we give at input, the same power will be reflected at the output. So in that case, EP into IP should be equal to ES into IS. Yes, I hope you've understood this. Yes, yes or no? Now, ES upon EP can be written as IP upon IS. Yes, I can write it IP upon IS. Now just remember one thing, this NS upon NP is always equal to ES upon EP. Okay, NS upon NP is always equal to ES upon EP. This combined is called the transformation ratio. I mean, greater the number of turns, more will be the induced EMF. We have seen this in the very basic lectures of electromagnetism. Yes, if, if we increase the number of turns, the induced EMF automatically increases, right? So NS should be directly proportional to ES and NP should be directly proportional to EP. Now see, ES upon EP can be regarded as NS upon NP. Now this combined equation is rather called the transformation ratio, which in your books is written as small n. So this is your transformation ratio. Now you get to know a number of things. I mean, it involves a lot of conclusions. When a transformer will act as a step up transformer, when the transformer will act as a step down transformer, you will get everything from this particular equation. So before we move on to that equation, I mean, this was the equation. Let me write it here once again. ES upon EP is equal to NS upon NP is equal to IP upon IS. Just note that the current part is having a reverse relation. Okay. Now, before I explain you the basic part, the basic terminology of how the voltage is stepped up or stepped down, let's talk about this very exciting Unacademy Prodigy, right? Unacademy Prodigy test. The test was supposed to take place on 4 days. The three of the dates have already, gone. Today was the third day. The next day is 13th. I mean 13th of Feb. If you have already taken up the test, well and good, no problem. But in case you haven't taken up the test, you haven't taken up the Prodigy test, so 13th Feb is the date. What you have to do is you just have to enroll yourself. Why? Because the enrollment is absolutely free. You don't have to pay anything to get enrolled. And on top of that, you get to earn prizes worth rupees 10 crores. I mean, just see. I mean, these are the this slide shows you the details of the test. Now, these three dates have already passed. The only date left is Feb 13th, right? So you can use this particular date, and on this particular date you can give the test. Now this is the list of the prizes that can be won. Just look at the prize. I mean, rank 1 you win a MacBook Air, rank 2 and 3 you win an iPhone, rank 4 and 5 you win an iPad, rank 6 to 40 you get a chance to win Amazon Echo Dot, and for 41 to 100 we have got Amazon vouchers for all our learners. So it's a win-win situation. You don't have to, you won't be losing anything. All you have to do is just enroll for the test and give the test. You might win exciting prizes. Okay, so it's a very good deal. Now let me brief you about this these batches that we are having. There are two champions batches in English. The batches in which I'm teaching, the very first is the batch for ICSE 10th, and the other one is for ICSE 9th. The batches are called champions. Okay, these are champions batches, and the best part is if you get the subscription for 10th, you'll get the subscription from 11th to 12th free. The same applies for class 9th also. If you get a subscription for 9th, you'll be getting a subscription from 10th to 12th absolutely free. So it is again a win-win situation. Now let me brief you about the exciting features of Unacademy. The Unacademy offers you to learn at the comfort of your home. Okay, you get unlimited access to all the courses. All the courses can be accessed unlimited number of times through the top educators. I mean, you get to learn concepts through top educators. There are regular doubt clearing sessions. In fact, I would say every fourth session for a plus subscriber is a doubt clearing session. Okay, we the batches that I have told you about, they cover all the courses, all the entire content is covered extensively. Okay, We have regular tests, daily practice sessions, and there are weekly mock test series, live quizzes, MCQs. We have got subjective test series as well. So overall, it's a complete package that can be very helpful for you. Now let's talk about the step up transformer. I've told you there can be two types of transformers: step up and step down. Step up and step down. Now the name itself tells you step up means you are increasing the value. Okay, I mean, at input, if it is input means primary, if at primary you have got EP and at secondary you have got ES, and if I am saying that it is a step up transformer, is step up, that means secondary will be greater than primary. Yes, and you know the relation, ES upon EP is equal to NS upon NP is equal to IP upon IS. This is the relation. Now, if ES is greater than EP, obviously IP will be greater than IS. Yes, and no, I mean, here the inverse relation will be applicable. Why? And you will be having NP less than NS. I guess no. Let's correct it. Select the eraser. Okay. Let's see how it goes. See what actually happens. I guess the pen has stopped working. There is some technical issue with it. No problem. See, what I want to convey is it is stepping up the voltage. Hi beta, high tech blaze gamers. Long time. I mean, you were a regular participant in the YT sessions, but seeing you after a very long time. All good? I hope you're doing well. Yes? Hope so. I guess the pen is stuck. No problem. I don't need a pen now, so I'll be kind of telling you without the pen as well. That will not kind of hamper the prospects. So, right. I was telling you about the step up transformer. Now, if the transformer is a step up transformer, it will obviously be stepping up the voltage, right? Now, at the output, what we have a secondary voltage. Yes, at the output, we have a secondary voltage. The output side is a secondary side, right? So, if we are having a secondary side at the output, what does it mean? If it is stepping up the voltage, it means the secondary voltage, the secondary EMF will be greater. If the secondary EMF is greater, obviously the number of turns at the secondary side will be greater. Why? Because this is the relation. Now, just try and relate the current part. Now the current will follow an inverse relation. Now IP will be greater than IS. Yes, for a step up transformer we'll rather be having IP is greater than IS. Yes or no? See, this part is greater, this part is greater, so this part has to be greater. So this is how it goes. Fine. Now in your board examinations they ask you, I mean, they draw a diagram. Let us suppose this is a diagram and this question has been asked, which type of transformer is this? Just try and analyze. What you have to see is you have to see the number of turns. This is the primary side with the number of turns NP. This is the secondary side with the number of turns NS. You can clearly see that NS is greater than NP, and as soon as you get to see that NS is greater than NP, you'll have to conclude that it is a step up transformer, right? So what does a step up transformer do? It is steps up the incoming voltage. If you have applied 50 volts, you'll obviously be getting a value greater than 50 volts, right? Now, second, we have a step down transformer. Now, what does a step down transformer do? I have to again write the equation which says ES upon EP is equal to NS upon NP is equal to IP upon IS. This is the equation. Okay, we call it transformation ratio. and we are talking about step down. Fine, step down. So now what will happen? EP will be greater than ES, okay, and NP will be greater than NS, right? And IS will be greater than IP, okay. And then one very important aspect here, the transformation ratio will be less than 1. This is a very important question. Hi Harsh, how are you? Hope you're doing well. This is a very important question. This has been asked once in a board examination. Yes, Harsh, I've got you. How are you? Hope you're doing well. Welcome to the session. Yes. So I was talking about the transformation ratio. And in this case, the transformation ratio will be greater than 1. So, you have got 2, 3 very interesting questions which are normally asked in the board examinations. The very first is about the transformation ratio. The second one is about the number of turns, where you will be having greater number of turns and how and when. So, these are types of questions which they normally ask. Okay. I hope you have understood the logic about the step up and the step down transformer. You have a number of questions as well. We'll be discussing few of the questions in the subsequent sessions where I'll tell you how to go about the transformer questions. They are very very easy. Okay. And there is some a very popular question. We all have used transformers in the generation of power. You have seen. Yes, Harsh. I mean, this session is for the working of transformer. It is a very generic topic, a very generic topic of science. Everyone can watch it. And I have taken up the topic in such a manner that everyone finds an application, right? So you can very well watch this. There is no problem. Okay, there is no problem at all. Now let me tell you a very practical use of transformers. If you remember the generation and transmission of power, I've told you 33 kV is first converted into 132 kV. I mean 30 to 132. What happens at the first stage, at the generation point? I mean, if you are a class 10 student, you will be able to relate. In the generation point, we use a step up transformer. Yes. Later on, at the distribution point, we use a step down transformer. Why? Because ultimately we have to step down the voltage to 220 volts, because 220 volts is the voltage that we are actually going to use. Okay. So we use both step up and step down transformers in the generation and the transmission of the power. Okay. I hope you understand this. Yes. Come on, I need a thumbs up if you have understood this. I hope yes. I mean, I've tried to explain it in the easiest possible manner. The working of a step up and a step down transformer. And you get sometimes you're asked a question regarding the losses in the transformer as well. I mean, there are certain losses which take place. The highlighted ones are the core loss. Just make a note of this. The core loss, the copper loss. The copper loss is like I square R loss. And then you have this eddy current losses as well. So there are certain losses which do take place, and I have given you an explanation as well as to when you have to use which particular kind of transformer to ensure that the losses are minimum. Yes. Okay. Now let me tell you about this Unacademy Plus subscription part. First of all, let me tell you my code. My code is Kalyan Live. Okay. This is my code. KALYAN LIVE. Kalyan Live is my code. Okay. Now just look at the subscription part. I mean, it's very, very commendable. Class 10th, 11th, and 12th subscription. If you are in class 9th, and I mean, if you are in class 10th, you'll rather be going for 10th, 11th, and 12th subscriptions. So in that case, these are the pricing. If you are in class 9th and you're going for 9th, 10th, 11th, 12th subscription, these are the pricings. Okay. The best part is I've told you in all the batches. If you're opting for a 3-month subscription, the effective price will be 2500, and if you're using this code, you'll be getting a 10% over and above discount, which adds value and obviously saves a lot of money for you. Okay, so you should rather go about it. It's not at all problematic. Okay. And then if you are 9, 10th, 11th, 12th, you're going for 9, 10th, 11th, 12th subscription, it starts for minimum 6 months, and these are the pricings. Again, the pricings are very, very reasonable. I mean, so it's a very reasonable price, so you can rather go with it. Okay, it does add value. Fine. Now, in case you have found this session interesting, so these are the details of my upcoming session. In these particular session, we'll be discussing few very important topics. Like tomorrow 6:30 p.m. I have got a special session where I'll be discussing the sample question paper. Okay, right? Then day after tomorrow, we'll be studying calorimetry. One short lecture. I mean, in a single shot, we'll be completing the entire calorimetry. That lecture, that session is going to be very, very interesting. Then again on 10th of Feb, we'll be discussing the sample question paper. See, let me tell you how we'll be going about. We won't be discussing the calorimetry or heat questions on 7th. On 8th, we'll be discussing calorimetry, and then again on 9th, we'll be discussing the rest of the questions. Okay, so it will go about this that way. And on 12th of Feb, we are going to have the first pole war. I mean, class 10, the first pole war is going to happen on 12th of Feb. Okay, so in case you have found the sessions interesting and you want to attend these classes, just download the Unacademy app, go type my name, Kalyan Krishna Awasthi, search me. You'll get the details of all my classes, all the classes which have already commenced and all the classes which are upcoming. So just enroll for that classes. I hope and wish to see a lot of you in the next classes. Yes, fine. So that is all from my side in this particular session. In case you have not subscribed us on YouTube, this is the right time to go about it. Okay, subscribe us, like, share. I mean, like the channel, like the video, share it with your friends. If you're not subscribed, subscribe it, and you can obviously download the content as well, so that adds value to your preparation. This is all from my side. Good evening, thanks, and stay connected. Most importantly, in terms of Unacademy, let's crack it.